All right, Pythagorean theorem. And again, you don't have to copy down all the words up here. I would just say mainly get the diagram down. Kind of the side of a house here. He's got the ladder here. I'm going to read you the question so you kind of know what's going on. It says Kevin is an insurance adjuster. He needs to climb onto the roof of a house to inspect for storm damage. The roof is 14 feet above the ground. For safety, Kevin must extend the ladder 3 feet above the edge of the roof. He must also keep the foot of the ladder 5 feet from the house. Is a 20-foot ladder long enough for this job? So let's label what we know on this picture right here. We know that the roof is 14 feet from the ground. So I'm going to put a 14 right next to the house there. We know that the ladder has to be 5 feet away from the house. We know that it's a right triangle. It's a 90-degree triangle, 90 degrees. What we need to know is how long the ladder needs to be to satisfy this condition right here. Now we do have a Pythagorean theorem that will help us. You may have seen this already, you may not, but the Pythagorean theorem says that a squared plus b squared is going to equal c squared. Now how do I know which sides are a, b, and c in my triangle? That's the key. So if we have a right triangle, here's my right angle. Anybody have an idea where a and b are located? Okay, but in this triangle they would be called what? The two legs, right? Or the base and the height. So your A and your B. What can we say about A and B without a shadow of a doubt? We know that A and B are what? The smaller two sides. A and B must be smaller than C. Why does C have to be the biggest side? Because it's across from the largest angle. That's a 90-degree angle. These are both acute angles. This is C, it's called the hypotenuse, and it has to be across from the biggest angle, 90 degrees, so it has to be our longest side. So A and B have to be the two shorter sides. This leg and this leg are definitely, each of them are shorter than this one. Now together they're bigger, but by themselves they're going to be shorter than C. So our Pythagorean theorem in this equation over here says that we have 5 squared plus 14 squared, it could equal c squared. This would be our c right here. We have 25 plus 196 equals c squared. 25 plus 196, 11 carry the 1, 11, 12 carry the 1. It's like 221 equals c squared. Now how do we get c by itself? This is what we worked on in the last section. Square root both sides. So we're going to square root the 221. So now c equals square root of 221. Let's find out what the square root of 221 is. 221, and we're going to do inverse of x squared. I think it's minus 30. So it's going to be 14.9, we'll call it. So we'll use our 14.9 by rounding it up. So C is 14.9. So how long does the ladder have to be? Read the question carefully. What does it say right here? It's got to be 3 feet above the edge. So right here to right here is 14.9. It still has to be 3 feet above that. So how long must the ladder be? Must be 17.9. So does he have enough if he has a 20-foot ladder? Yeah, so his 20-foot ladder would extend past the 3 feet and he'd be fine. So that is how the Pythagorean theorem works. Okay, so here is the exact wording on the Pythagorean theorem. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. That's exactly word for word what they say in the Pythagorean theorem. The square of the length of the hypotenuse, this c squared, is equal to the sum of the squares of the two legs. So it says create an if-then statement for the Pythagorean theorem. What could we do for an if-then statement? If it's a right triangle. Let's start there. Then what happens? If it's a right triangle, then the square of the hypotenuse is equal to the sum of the squares of the two legs. So there's an if-then statement for your Pythagorean theorem. If it's a right triangle, then the square of the hypotenuse is equal to the sum of the squares of the two legs. Another way to say it is just a squared plus b squared equals c squared. That is what we're going to be talking about in this section. These are going to go pretty quick. They're not long examples like we had yesterday when we were doing all those radicals. This one won't take quite as long as that. Give a second to catch up. Remember, on Thursday, we'll be checking notes 5.1, 2, and 3. And 5.3 you'll watch online tomorrow night, not tonight. Tonight there is other homework I'll tell you about. It's not hard. Shouldn't be. Shouldn't take long. Okay, moving on. Okay, so find the length of the diagonal of a square with side A. So we have a square. Let's make it a different color because it's too dark inside there. We have a square and the length, each side is A. So there's an A there. There's an A there. Our job is to find the length of the diagonal. Okay, so that's what we're looking for. Oops. Let's start over. So our job is to find this X. Or actually we could call it C because it is the hypotenuse of our right triangle. Because in a square you have to have right angles. So this right down here must be a right angle. So we could say that we're looking for C. We're looking for the hypotenuse of this right triangle right here. Because it's a square, and what do we know about a square? All four sides are the same, so they both have to be A's. Actually, all four of them could be A. So to get my Pythagorean theorem here, I'm going to put A squared plus A squared equals C squared. Okay, so A squared plus B squared. Here's A squared, here's B squared, but in this case, since they're both the length of A, they're both the same length, we could just put A squared plus A squared. So really, I can combine these, and what do I get? No, you're not multiplying. 2A squareds. You've got 2A squared. Now, if I was doing A squared times A squared, then you'd have A to the fourth. But A squared plus A squared is 2A squared equals C squared. Now what? Okay, we could square root both sides, but I wouldn't do that yet. I would divide by 2. Oh, wait, no, we want C. You're right. Never mind. I thought we were looking for A. My bad. Yeah, we want C. We're going to square root both sides. So that's going to cancel out here. You're going to get C equals, what do you think there? Not 2A. A radical 2. So C is going to equal A times radical 2. Okay, now why is it A radical 2? let's look back at this right here. This, if we break it down, to be radical 2 times radical a squared. That's what this is right here. Radical 2 from here to here, radical a squared from here to here. So can we take radical 2 out of the square root? That's not a perfect square. That's got to stay inside. That's here. What about the square root of a squared? Doesn't the square root cancel out a square? And it brings out the a. That's why that a comes out. So it's going to be a times radical 2. Now I want you to look at something here. Notice how both sides were a's. And what was my hypotenuse? A radical 2. Let's say that I had a square and both sides were 3's. Then what do you think this hypotenuse is going to be? 3 radical 2. It's going to be whatever the side is times radical 2. Whatever this side is, you're going to take that side and times it by radical 2. Because that's what we did here. We took the a's and then multiplied it by radical 2. So you got a radical 2 for that one. Let's look at the next example. The hypotenuse of a right triangle measures 41 inches. Okay, so you have a right triangle. Hypotenuse is 41 inches. One leg is 9 inches. Find the length of the other leg. That's going to be our x. How would I solve that with my Pythagorean theorem? What could I set up? 9 squared plus x squared, that's my a and my b right here, equals 41 squared. Could you still solve for x here, even though it's on the same side with this 9 squared? Yeah, you're gonna basically subtract 81 on both sides. You know why I'm subtracting 81? Because 9 squared is 81, right? So let's find out what 41 squared is first. 41 times 41. Let's see what that is. 41, and we'll hit the x squared button, and you get 1681. 1681 minus 81, you're going to get 1600. X squared equals 1600. That's going to come out nicely, huh? When you square root both sides, what are you going to get for your x? 40. Good. 40 times 40 is 1600. So that would be 40 inches. That would be the length of your other leg. Okay, here's a little key side note here for you. Pythagorean triple. If 3 positive integers, you remember what an integer is again? Whole numbers, right? Not decimals, not fractions. If 3 positive integers, a, b, and c, satisfy the Pythagorean theorem, then it's called a Pythagorean triple. The most famous Pythagorean triple that you're going to see is a 3 by 4 and a 5. What's 3 squared? 9. What's 4 squared? 16. What's 9 plus 16? 25. What's 5 squared? 25. So this is probably the most popular Pythagorean triple right here. It's 3 whole numbers that make the Pythagorean theorem work. Anytime you've got 3 whole numbers that makes the Pythagorean theorem work, then you've got what we call a Pythagorean triple. So it's positive integers, not decimals, not radicals, not fractions, just 3 whole numbers, where a squared plus b squared equals c squared, then you've got what we call a Pythagorean triple. So that's a triple. Not a triple in baseball, just a triple. Again, these will be loaded later. I didn't look yesterday's yet, but I'll load them soon. I need to move to the last second to the last slide and the last one. Okay, what is the converse of the Pythagorean theorem? What's the converse? Remember the conditional statement we said, if it's a right triangle, then c squared equals a squared plus b squared, right? So what could I put? If c squared equals a squared plus b squared, then what has to happen? if c squared is equaling a squared plus b squared right here, then it has to be a right triangle. Has to be a right triangle if c squared equals a squared plus b squared. Then it's got to be a right triangle. Okay, so Jerome wants to be sure that the corner of an iron brace is a right angle. How can he check that the brace forms a right angle? What would he need to do to make sure that he's got a right angle when he's measuring his sides and stuff? He has to make sure that c squared equals a squared plus b squared. If c squared equals a squared plus b squared, then what does he have to have? A right triangle or a right angle there. If it's equal, it's going to be a right angle. What happens if that's not equal? That's not a right triangle. Could we tell what kind of triangle it is? And that's a yes right here. The next part is talking about what kind of triangle it is. And I just told you that if c squared equals a squared plus b squared, you've got a right triangle. If c squared is less than a squared plus b squared, you've got an acute triangle. And if c squared is greater than a squared plus b squared, you've got an obtuse triangle. So you can kind of see that if c, and it makes sense, if c squared is smaller, what kind of angle is a smaller angle? It's acute, right? Acute or smaller. If it's equaling, it's going to be 90, but if it's smaller than that, it's going to be acute. If c squared is greater, what kind of angles are greater than 90? Obtuse. So you know if c squared is a bigger number, it's going to be an obtuse triangle. If c squared is a lesser number, it's going to be acute. If c squared is equaling it, it's going to be a right triangle. So what kind of triangle has sides of 9, 12, and 20? Which one is my C? The 20 is my C. These are my A and my B right here. So I'm going to do 20 squared, and I'm going to do 9 squared plus 12 squared. And I'm not going to put anything in here yet, because I want to see what kind of triangle it actually is. So 20 squared is 400. 9 squared is 81. 12 squared is 144. So I've got 400, 81 plus 144. That's going to be 225. 400 is greater than 225. So what does that tell me? It's an obtuse triangle. It's not a right triangle because they're not equal. It's not acute because it's not less. It's a greater angle. Greater angles are obtuse angles. So that would be an obtuse triangle. And then there's just one last page here, which I think is pretty short too. Wanted to check. We doing okay? Yeah. And the last one. So you can now you can kind of tell what kind of triangle anything is with three sides. First off, though, what do we have to be sure of to make sure it's a triangle? That A plus B has to be more than C, right? Is this 9 plus 12 add to more than 20? Yeah, it does. That's 21. Barely more. So you can see why it would be pretty obtuse. But yeah, it's definitely more, so it was okay. Is the following triangle a Pythagorean triple? If not, then what kind of triangle is it? Is that a Pythagorean triple? Do we even know if it's a right triangle? Which one's my C? Okay, so 14 squared. I don't know if it's equal yet. Not sure. I'm going to see. 5 squared and 12 squared. What is 14 squared again? Good, 196. 5 squared we know is 25. And 12 squared we know is 144. So 196 What do we know? 25 plus 144 is 169. Is it a Pythagorean triple? No. Why not? Because it's not satisfying the Pythagorean theorem. It's not, c squared is not equal to a squared plus b squared. Has to be c squared equaling a squared plus b squared to be a triple. This is not, this is going to be a greater than, the c squared is greater than a squared plus b squared. So what kind of triangle? Obtuse again. Another obtuse triangle. The last one, we have sides of 1, 1, and radical 2. What kind is it? Is it a Pythagorean triple? Is it a right triangle? What is it? Well, I could answer one of these two questions already. Which one could I answer right now? Could it be a triple? Are all these whole numbers? Radical 2 is not a whole number, so definitely not a Pythagorean triple. Now, it could be a right triangle. Which one is going to be my C? Radical 2 is like 1.4, so that's bigger than the 1. So radical 2 squared, we're going to see if that equals 1 squared plus 1 squared. What is radical 2 times radical 2? Number 2 comes out. Anytime you multiply the same radical, that number comes out. Square root cancels out the square, you're going to get a 2, that comes out. What is 1 squared? Plus another 1 squared. So what can I say about 2 equaling 2? What does that tell me? Right triangle, yep. That is a right triangle when 2 equals 2. So now you know the Pythagorean theorem. A squared plus b squared equals c squared. You've got a right triangle. And then you know, now you can see if it's obtuse or you can see if it's acute just by looking at the Pythagorean theorem.